Symbolic versus Connectionist machine learning. Reason without hallucinations in large language models by hybridizing with neural networks with code. So, welcome back to another video. I would like to tell you more about something that is likely going to be very common and may even get us to artificial general intelligence. And so, this post was actually written, basically presented at a local meetup, and after that, things started to really happen even more. So there was a ChatGPT combination with plugins released by OpenAI, and then AutoGPT became increasingly popular. So let me tell you about the things happening in this area and what's likely going to be. And I would like to put this into a broader context and give you more details. So, okay. So, large language models, they perform trillions of calculations and they still produce hallucinations and poor reasoning. GPT-4 reduced this issue with reinforcements from human feedback, but the issue is still there. While, people are also have hallucinations. Maybe you had false memory today, maybe. And so, for example, if there's a crime, people don't always remember and describe the situations the same way. So there must be some hallucination there as well. So people don't remember, sometimes they don't reason 100%. So what kind of tools do we use to improve our reasoning? Well, we write down symbols, right? We had a language, we developed words, and then we started to write words down. And we use the words to write down rules. And then we can go back and read those symbols later. They are immutable, written on some paper. And we can as well execute the rules like laws. We've started to write down laws and execute the laws such that there's some sort of structure in the society. And we also developed mathematics, and which led to extremely successful other things like accounting, physics, engineering, software engineering. If you think about it, these symbols that we use are even part of our DNA. DNA is made up of actually 4 symbols, I think. And maybe it's something about them being more resistant to noise. Maybe that's how these discrete symbols came to be. And also these symbols and symbolic rules, we started to use them in computer programs, started executing computer programs, and these computer programs take crystal clear inputs and they produce crystal clear outputs. And these kind of aspects seem to be kind of missing in large language models. So what do we have? What am I comparing? So on one hand, we have feelings and intuition, which are represented by neural networks. On the other hand, we have symbols and rules, which are represented by algorithms. And currently, large language models map from symbols to symbols, but they are more about neural networks. And what we are talking about is combining this based on previous approaches with symbols. Also, if you think, for example, mathematics, maybe you remember some kind of equation that you used in the past. So all these equations where you have an x, for the x you can put 100,000, million, 10 million, trillion, gajillion. It extrapolates to infinity. Whereas in neural networks, there's always some kind of limited domain. Algorithms are, for example, decision trees are very readable, quite understandable. They don't have some kind of hidden a representation, while neural networks do. They have these embeddings. I have more things about embeddings on my blog. You can follow me on my blog and subscribe to my newsletter. You can follow me on Twitter. Okay, and also, because when you have this very specified input and output, you can combine these things, you can combine algorithms, which is extremely useful, and we use it every day. Also, on one hand, in this connections domain, you sort of find patterns in the huge amount of data, whereas in the symbolic domain, you write great rules which help you. Okay. So in 1980s, the symbolics, these algorithms, these rules were amazing. AGI was just around the corner. We were about to just use these expert systems which used a set of rules that were written down by programmers, which combined with some domain experts. And together they've collected this large set of rules which was able to solve problems. And the people were building specialized hardware for this kind of systems. And it all looked great. AGI was already here. And suddenly it collapsed. What happened? So there are several issues with this approach. So with writing down rules, it's kind of difficult itself. You have to be expert, and you actually have to have description for the rule that you are using in your domain, because sometimes the experts don't even know what they are doing. They have something in between words which they cannot describe in symbols. You know, actually writing things down, that's actually a very useful thinking tool, right? Like, let me get back to that later. And we were not able to get to the AGI because, for example, some of the rules were very hard to do. Some of the programmers, experts together was very expensive combination. The hardware was expensive, and there were approaches that started to get traction, and symbolics were mostly abandoned. In 1990s, Hinton, Lacan, and Maggio led the neural network revolution, which was the connectionist revolution, which is what is dominant now. And you know, deep learning, that's what the connectionist approach is. It's going to be able to solve everything, you know. And neural network supervised learning, AlexNet in 2012 got top 5 error rate of only 15%. You know, unsupervised learning of distributed representations, for example, word-to-vec maps words to vectors, transformers in 2017 map entire sequences of words to contextual vectors. And then recently, 2022, I think, reinforcement learning from human feedback takes these huge models which have all the personalities on the internet trained in, and instead they actually fine-tune this language model to get you something useful on the output, to talk to you, and to have sort of one helpful personality instead. And so now the OpenAI is hiring experts, and people are building dedicated hardware, and AGI is just around the corner, right? So I think you've heard that somewhere before, right? And so we are in much better situation in 2023. Is there going to be another AI winter just as the last time? Well, you know, the last time it was just before the economic crisis. Maybe there will be one now as well, but we are in much better situation now. Like this reinforcement from human feedback, it's a much bigger lever. So you don't actually write the rules, you only compare the outputs. Now it's getting harder, but it's still oftentimes much cheaper to compare the quality of the answers, to score the answer, to say if the answer is correct, than than to write it from scratch. And it also reduces hallucinations. This thing, you can saw it on GPT-4, there's much less hallucinations. But can we actually do something like humans did? You know, use this writing into symbols to create rules. Can we do something like that? Like as I mentioned, the humans actually find writing as a very useful tool for thinking. Like it forces you to make decisions, and you can review it later, and you select the right words. And if you do that in the right sequence, maybe it helps you to find something new or crystallize your ideas. And how can we hybridize algorithms? How can we hybridize code with neural networks? How can we do reasoning? For example, there is this chain of thought prompting approach, which I have actually posted about, which you know, if you think about something very difficult, do you think about it that you immediately answer the correct answer, or do you actually do multiple steps? You're trying multiple approaches, so you are thinking step by step. That's what's done in large language models as well. You can as well do the symbolic approach of taking the large language model, predicting the next words, but instead fill in templates. You can also do self-consistency prompting. That's something what AlphaCode does, that you produce many code samples, and then those that cluster together, you select them. You can do something like Toolformer, which actually writes code. It just writes code as some of the other papers. It can learn that very quickly from a couple of examples. For example, it can call a calculate function, which then, you know, do you yourself calculate everything on your own, or do you tap on a calculator and get the right output? You can do this with large language model as well. You know, there's AutoGPT, which recursively plans tasks, perform the tasks, which is gaining huge traction. And you know, there are what other approaches there are. There's AlphaZero, which plays chess, and it plays chess such that it searches for the best possibilities of next move, and this is called neural guided search. RetroTransformer has entire training set stored, and it can search through it when it tries to generate the next token. And there's a DreamCoder, which is like an even bigger combination of these things, which actually searches algorithms, and it first solves simpler problems. Then it finds useful methods to store in its library, and then it does it again. And similar things can be done with images. ViperGPT can answer questions about images. Jan LeCun, which was big Connectionist driver, is now written augmented large language models with some other people. Francois Cholet is mentioning this issue and actually developing a data set on which GPT-3 got 0, and I'm not sure what GPT-4 gets on there. And what OpenAI is doing, well, as I mentioned, they are doing this reinforcement learning from human feedback. However, it's getting more and more difficult because the models get better. It's very hard to criticize the summaries from time to time that it generates. And so they started developing tools that help criticize the summaries. The model can do it itself. The model can criticize its own output. And they are starting to use this more and more, for example, for self-reflection in the large language model. And they will eventually, they produce the criticism, and maybe they eventually can close the loop. So the model can, train based on the best answer, which was produced by multiple iterations of criticism. And this gives bigger and bigger lever to the experts. And so who can you follow? What other people are talking about symbolic methods? So for example, on Twitter, you can follow Gary Marcus. It's always interesting to look at people who think about things differently. There's Francois Choula developing the dataset. There are startups, for example, Filter AI is using something called composable AI, so they combine planning with AI. There's Replit, Equilibrium Technologies, like many people do coding these days from large language models. So what do I think? Do we get to the AGI? Do I think we will get to the AGI? So I think like the AGI, probably not just yet. But is it possible in very, very long term? I don't really know. What about what the AGI really means? Well, if we define AGI as something that a person in 2023 can do, then, you know, we need to say the year, because after these tools are released, the people will improve. I think many people will rise up. I think we are underestimating many people. And in this, very new economy, I think we can do so many more things. Very long term, I don't know. What can happen? Nobody can know that, actually. All right, so let's connect. You can follow me on Twitter, YouTube, LinkedIn, I don't know, GitHub, Facebook. You can subscribe to my newsletter by email. And there are other posts, for example, Google Pathways, neural data compression, DeepMind Retro, DeepCoder. Did you like that one? You can read about that. I have about pruning, and also understand more how we got here. Maybe that would be interesting. There's another post about this. Through TF-IDF, Word2Vec, Knowledge Graph, and transformers to ChatGPT. Okay, thank you very much, and I hope to see you in the future. Enjoy and produce great work. I hope you got the gist, the juice of this symbolic versus connectionist machine learning, reason without hallucination in large language models by hybridizing neural networks with code.